UW360 is proudly supported by BECU, a not-for-profit member-owned credit union. Pacific Office Automation, copy, print, workflow, and IT. Problem solved.
The annual cycle of Arctic sea ice melt and growth is marked each September when the ice shrinks to its yearly minimum. And each September the question arises, will a new record minimum be set? Axel Schweiger and other polar scientists at the Applied Physics Laboratory of the University of Washington agree. Arctic sea ice volume is undeniably on a downward trend. There is less ice, and what ice there is increasingly vulnerable to dramatic losses in the future.
We've been interested in sea ice volume largely because we know that the sea ice has been shrinking. We also know that it's been thinning.
For decades, APLUW polar scientists have studied the Arctic sea ice, gathering data from under the ice, on the ice, and over the ice.
Drop, drop, drop.
Basically, we deploy buoys on the Arctic sea ice. And these buoys measure all kinds of things from air pressure, air temperature, ice temperatures, ocean salinities and temperatures. We'll deploy them from ships going up into the Arctic or throw them out of airplanes. This animation shows where all our buoys are. These red dots are the buoys, the actual positions of the buoys. As I start this animation, you'll see that the buoys drift around the Arctic Ocean, and the ice tends to drift out through the right here into the North Atlantic. One of the things we've learned is that temperatures are definitely important in driving the melt of Arctic sea ice, but what is also important and also part of global climate change and global warming is that the changes in wind change where the ice goes around the Arctic Ocean. So one thing we're seeing is that now that we're in this younger, thinner ice regime, this ice moves a lot quicker, it can be blown out of the Arctic a lot quicker. It doesn't have as much mass to survive a summer melt season.
From year to year, over the past 32 years, we've lost about 280 cubic kilometers of sea ice. How much energy does it take to melt that amount of ice? It happens to be just about as much as the U.S. consumes in energy in any one year.
Schweiger is focused on improved computer models of the Arctic climate, the key, he says, to predicting the future.
These predictions about the future help us assess what are the likely impacts on shipping, ecosystems, and other economic activities in the Arctic.
Probably the best known species or the icon of the Arctic is the polar bear. We immobilize bears and attach transmitters, and these transmitters allow us to track bears' movements over the ice year-round.
We find that the sea ice extent is decreasing in the region that the polar bears inhabit, and we're finding that the spring breakup of the ice is coming earlier and the fall freeze-up is coming later, so the polar bears have less time that they're able to spend on the ice hunting. Scientists are trying to understand the role of warming temperatures and changing circulation in how they contribute to the ice loss. But we know that it has an effect on polar bears, whatever the cause is.
Experts at APLUW are dedicated to ongoing research to track, understand, and help predict the dramatic changes in Arctic sea ice and what they tell us about global climate change.